underway.
Project Sentient. What if there already exists a system designed not just to observe the world, but to predict it?
What's going on?
A system capable of ingesting massive streams of global data in real time, tracking military movement, monitoring communications, analyzing patterns invisible to human analysts, and autonomously directing satellites toward events before they fully unfold. It sounds like science fiction, but according to declassified documents, congressional briefings, defense publications, and intelligence reporting, it's real. Its name is Sentient, an AI-driven intelligence system developed under the National Reconnaissance Office. And while much about the program remains classified, enough information has emerged over the last decade to reveal something extraordinary: a growing effort by the United States intelligence community to build an AI-driven system capable of automating surveillance, prediction, and intelligence coordination on a planetary scale. This is Project Sentient. Origins of Sentient is a program developed under the National Reconnaissance Office, or NRO, specifically within its Advanced Systems and Technology Directorate. The NRO is one of the most secretive intelligence agencies in the United States government. Its primary responsibility is the design, launch, and operation of reconnaissance satellites used for intelligence gathering across the globe. According to reporting by journalist Sarah Scholes, the Federation of American Scientists and declassified budget documents, development of Sentient appears to trace back to at least 2010, with major development phases continuing through roughly 2016. That timeline is significant. Much of Sentient's development predates the public explosion of modern AI systems by years. Long before large language models, consumer AI tools, or publicly accessible generative AI became mainstream, intelligence agencies were already developing highly advanced machine learning and predictive analysis architectures behind classified walls. In other words, while the public perception of AI accelerated dramatically in the 2020s, systems like Sentient suggest that sophisticated AI-assisted intelligence infrastructure may have been evolving quietly for far longer than most people realized, and in parallel with what we now recognize as modern AI development. That same year, the NRO issued a request for information seeking white papers related to self-awareness, cognitive processing, user interaction, and process automation. Those terms immediately raised questions, not because the system was literally conscious, but because the language suggested an effort to create a highly autonomous intelligence architecture capable of making decisions with minimal human intervention. Over time, additional details emerged. At the 2013 GeoInt Symposium, then NRO Director Betty Sapp described Sentient as part of an effort to make the agency not only reactive, but predictive. That distinction is critical. Traditional intelligence systems collect information about what has already happened. A predictive system attempts to anticipate what happens next, and according to multiple defense and intelligence publications, that is precisely what Sentient was designed to do. What Sentient actually is. Public descriptions of Sentient often compare it to an artificial brain. At its core, Sentient appears to function as a massive AI-assisted orchestration system capable of processing enormous volumes of data, detecting patterns across time, autonomously coordinating satellite resources, and identifying events or anomalies that human analysts might miss. According to Rand Corporation reporting, systems like Sentient are intended to free intelligence analysts from the endless task of sorting raw data, allowing them instead to focus on interpretation and strategic analysis. In other words, the machine handles the overwhelming flood of information. Humans handle the meaning. But the scale of that information is staggering. Reports indicate Sentient may integrate satellite imagery communications, intercepts shipping data, aircraft tracking environmental sensors, historical intelligence archives, financial information, and potentially even social media and commercial data streams. Former CIA analyst Alan Thompson described the ambition of the system in simple terms: to ingest everything. Tipping and queuing. One of the most important features associated with Sentient is something known as tipping and queuing. This refers to the automated coordination of intelligence systems. For example, one satellite detects suspicious movement. That information is instantly relayed to another satellite. A second sensor is redirected. Ground stations receive the update. Additional systems begin tracking the target, all in near real time. Instead of isolated satellites functioning independently, Sentient appears designed to transform reconnaissance systems into a coordinated intelligence network, an ecosystem, a distributed machine capable of dynamically shifting attention across the planet. According to NRO officials, the long-term goal involves AI-enabled constellations capable of interpreting plain language requests and autonomously coordinating sensors to deliver integrated intelligence reports. That means future intelligence systems may not simply collect information, they may decide how to collect it. Predictive intelligence. Perhaps the most controversial aspect of Sentient is its predictive capability. Sentient uses anomaly detection, behavioral modeling, and forecasting systems to predict likely adversary actions, force movements, emerging threats, and potential military activity. For decades, intelligence gathering has largely been reactive. An event occurs, information is collected, analysis follows, but predictive intelligence changes the timeline entirely. Instead of responding to events, systems attempt to anticipate them before they fully emerge. This introduces a deeper shift in how intelligence systems operate. When machine learning begins identifying correlations humans may not even fully understand or explain. The scale of surveillance. Sentient does not appear to rely solely on government satellites. Reports indicate the system may incorporate massive amounts of commercial data from private aerospace and analytics companies. According to military strategist Andrew Krepinovich, modern intelligence systems increasingly ingest data from satellites, ships, aircraft, mobile devices, social networks, environmental sensors, and countless other sources. The result is something closer to continuous planetary monitoring, a constantly updating operational picture built from billions of fragmented signals. And because machine learning systems excel at identifying correlations across massive data sets, the true power of systems like Sentient may not come from any individual source of information, but from the fusion of all of them together. Supporters of systems like Sentient argue that automation is necessary. Modern intelligence collection generates more data than human analysts can realistically process. Without AI assistance, critical information could be missed. But critics and military analysts have also raised concerns. One major concern involves infrastructure vulnerability. Even if the core system itself is secure, distributed satellite and ground station networks create additional attack surfaces that adversaries could potentially target. Another concern is automation itself. As predictive systems become increasingly autonomous, questions emerge regarding oversight, accountability, false positives, algorithmic bias, and decision-making transparency. If an AI system flags a pattern as suspicious, how do humans verify the reasoning? And if future systems begin autonomously directing intelligence resources at global scale, where exactly does human judgment remain in the loop? The bigger picture. Sentient represents something larger than a single classified program. It represents a broader transformation in how intelligence systems operate in the age of artificial intelligence. For most of human history, surveillance was limited by human attention. People could only observe so much, analyze so much, track so much, but AI changes that equation. This is where a broader concept becomes important: data fusion. Data fusion refers to the combination of multiple independent data streams into a unified analytical model. Instead of isolated systems producing separate outputs, everything is merged into a single, evolving picture. Individually, datasets are limited. Together, they become something more than the sum of their parts. What follows is not part of the documented record itself, but an analytical perspective based on observable trends in modern technology, artificial intelligence systems, and data infrastructure. At the same time, AI systems are increasingly embedded into everyday technology. AI agents now operate within phones, operating systems, vehicles, cloud services, and wearable devices. They assist with prediction, personalization, navigation, scheduling, and communication. These systems are typically framed as convenience features, but collectively, They expand the scale and resolution of behavioral data that can be processed across multiple environments simultaneously. Another example is the role of large-scale data analytics platforms such as Palantir, which are used across government and commercial sectors to integrate, structure, and analyze complex data sets from multiple sources. There is also ongoing discussion around next-generation vehicle safety and monitoring systems integrated into new models. These include driver monitoring systems, telematics platforms, and impairment detection technologies designed to improve road safety and reduce accidents. In some policy discussions, broader questions have been raised about how deeply future vehicles may become integrated into connected digital ecosystems, including discussions surrounding remote oversight, automated intervention systems, and what critics sometimes describe as kill switch capabilities under specific safety or regulatory conditions. These discussions are framed in terms of safety and compliance, but they also reflect wider questions about how control, autonomy, privacy, and data integration evolve in increasingly networked systems. Another example is the growing deployment of AI-assisted traffic camera networks capable of automatically identifying and tracking license plates, and in some cases, integrating facial recognition technologies. While these systems are generally implemented for law enforcement and public safety purposes, they also illustrate how advances in computer vision, automation, and large-scale data collection are becoming increasingly common throughout modern infrastructure. History shows that technologies introduced for safety or efficiency can expand in scope over time. Following the September 11 attacks, for example, the Patriot Act significantly expanded surveillance authorities in ways that continue to be debated today. This is not presented as a conspiracy or coordinated design, but as a historical pattern of institutional expansion following technological and political change. This perspective is not an extension of the source material, but an attempt to interpret how similar systems and capabilities are evolving across different sectors. The broader theme is convergence. Separate systems, government intelligence, commercial analytics, consumer AI, and infrastructure networks are increasingly capable of interacting through shared data and software ecosystems. Taken together, this does not imply a single unified system or intent. It reflects a structural trend in how modern technology evolves across sectors simultaneously, raising ongoing questions about oversight, transparency, and long-term societal impact. That does not mean every intelligence or security system becomes harmful, but it does highlight why public understanding, transparency, and accountability become increasingly important as AI-driven capabilities expand. If these trajectories continue on their current path, the distinction between observation, prediction, and automation becomes increasingly difficult to separate. Because one thing is becoming increasingly clear: the future of intelligence is no longer just about gathering information. It is about teaching machines to understand the world faster than humans can. Special thanks to the creators and contributors at Pexels and Pixabay, whose work helped make this project possible. Thank you for watching.